Okay, hello everyone. We're going to have some fun. Exactly in the way AI tinkerers are supposed to be done. So, this is Claudio. He started off as Claude Audio, and obviously we're in Italy and we use Claude, so it's Claudio. So what is it? It's AGI, you can synthesize and loading. This is what this is. This is my playground for testing algorithms, having fun. Testing out structured generation stuff, just making sure that the responses I get are correct. And then here we have, I hope my grandmother's not going to send me a message wrong here. Okay. So we have standard synthesizer stuff, sequencer. But then you see underneath we already have some constraints, which is pattern DNA, complexity, entropy, and harmonic content. So what this is going to do is, when we set up our synthesizer and all parameters for it, just imagine this, which is just further down. We have 4 agents. The agents are essentially analyzing everything. They're getting a message from the conductor as to what to do next. Then they're going to have a think about that between them, and then they're going to give an answer. And the conductor, based on these kind of scores, which are in reality they're extremely crazy complex, based on psychoacoustics and the internal mind of the LLMs, it's going to give us new patterns, and it's going to change the synthesizer sounds. So let's just get this running from there. Okay. I feel a little crazy sound. So now Claudio's going to send out a message to the servers. Okay. And in time, it's changed. It's enhanced our pattern. It's kind of doing it on the fly at the moment because you haven't given it an exact definition of what we want. So, and it can get crazy, I'm going to tell you now. Here are the tracks that we have at the moment. We obviously have plenty more tracks that we can add. ADSR, envelope, filters, all this kind of stuff. We'll add a little bit of chaos. We always like a bit of chaos. Okay. It's gone a little crazy. So I have a prompt already. Electronic Kraftwerk style sound from the 90s, electro. We can fall into little minimas, so we can actually be spinning around some sounds where it doesn't make any sense for a while, and then it tries to interpret it. But we're going to give it a little hand. Let's give it a little hand first. There we go. Okay. So already it is sounding rather Kraftwerky. And what's really interesting about this is I'm not telling it, describing it what Kraftwerk is or electronic is and stuff like that. I'm literally asking it in the prompt to look deep into itself and to understand its own understanding of synthesis, and then change the parameters, which I explained to it. You know what an oscillator is, you know what filters are, you know what ADSRs are. Do it. And it doesn't, which is kind of crazy. So we also have stars. It's going to change this into a techno star. The stars take a little bit longer because that's a different kind of thing, different kind of message. Okay. Usually the techno style will give you something like a 4/4 boom boom thing. The electro will be different. The minimal style will spread out. The minimal style will spread out all the notes and actually have really short decays. Claudio also knows that if the beat's really fast, then it should, if the tempo is really fast, then it should shorten all the notes, so we just don't start causing chaos. It does really have an extreme understanding of psychoacoustics and all these kind of things. Okay, shh, I'm getting quiet. So let's have a look a little bit further up here, because obviously I've been looking at this for a couple of weeks, and it's easy for me to go through it, but it would be nice if I explained it to you properly what's actually happening. So we can see here, fallback conductor. Okay, the fallback conductor has decided to just ignore all the other agents. We have a rhythm agent, which is mixtral, harmonic agent, which is llama, structure agent, which is llama, wildcard is gamma, our conductor is llama, and the style agent is llama, but it's 70B. Okay, for pattern analysis, we have mathematical, different types of analysis inside. Okay, let me explain this AGI, I think, for you. What we're actually doing here, this is set up as a big playground for all my algorithms. So the reason for this is that I want to train some AIs, and I want to make sure that they understand exactly what I'm talking about and that I can speak to them correctly. So what's really happening here in the background is the DNA agent actually has a genetic mutation engine, and it keeps 100 of the previous mutations, and it makes little children and stuff like this. And then there's another AI which talks to it and essentially picks out the ones based on our prompt that it would like to use. Everything in here is stored, so we have 16 by 16 patterns, 8 by 8. The parameters are 32 and then 64. The whole thing creates a 5 by 12 tensor. So then this is a data creation engine. And what it's actually doing is it's creating these tensors in the background. And if I have a day where I really enjoy what Claudio is doing, then I can say to it, well, remember last Thursday, I really like what we were doing. Let's just train a small neural network on that. Let's see what we can get out of it. Then we can do loads of other operations on it, like similarity stuff. And then pull out the actual data. You know, what was it about last Thursday that I really liked, or was it? And then we can pull it out and we can learn from it. Not only that, but I can learn from it. Okay, we have all sorts of crazy things. We have polyrhythm analysis, frequency domain analysis, harmonic content relationships, syncopation analysis, simplicity and predictability, and then the one thing that it's doing when it creates the tensors, it does actually label the different parts. So we have a meta part for the tensors. So stuff is labeled. Upbeat, downbeat, I'm going to put a little like and a dislike to it, all this kind of stuff, just to make sure that when I get the data out, then I am able to train my little buddy correctly. Okay, there's proposal functions, decision validations, the agent selections chooses the optimal agents based on intent. It's really a nice little piece of work. We're approaching 20,000 lines of code here. Okay, so we've got the conductor has democratic mode, where we can see here it's just randomly gone ahead and decided from the DNA pool and what we've done in the past to do this, to whatever it did. Then we have competitive mode, weighted scoring. Sequential mode, where it combines the insights from all the agents on an equal amount. Chaotic mode, where it randomly selects certain amounts of the agents. And quality assurance, we have a validation after all this. Okay. A little bit about the genetic algorithm. We have the standard generation, parent genomes, mutation history, ancestry complexity, and then the entropy at the end, information theory stuff. Then another thing that it does is the agents can call tools. So when the agents can't interpret things correctly, they can decide to call tools like Euclidean algorithms, certain prime sequencing kind of things. He looks at phase relationships. We have special fractal recursion, harmonic resonance, polyrhythmic shifts. These are tools that they can call for themselves. Now, these are all some in here. There's also some of my tools that are actually used for reinforcement learning. So when we go from higher dimensions into lower dimensions, we use things like TS&E, UMAP, and that kind of thing. And I have my own little special tool for it. That's one of the things that's in here as well, and it goes through the DNA engine, goes through the whole past, and it tries to look at the future. It takes everything that we've done, it looks at where we are now, our intent, and it tries to predict the future. And by predict the future, I mean it just tries to predict the settings in our synthesizer. Okay, let's... One of the things we also have genetic fingerprinting, evolution steps, special crossovers that go between genes, fitness improvement, slight bit of reasoning. Well, I don't quite believe it's reasoning. There's a couple of functions in here where I just said to Claude, okay, Claude, I'm looking to do these things, come on, give me a hand. And he put them in, and I haven't looked at them for about a week, so really good. So in the evolutionary analysis, we have information entropy, and it actually calculates the Shannon entropy of the patterns, genetic diversity, fitness landscape, selective pressure, specialization, risks. These are tools that it uses to just to make sure that it's not always doing the same thing, but it's kind of keeping within our guidelines. And obviously, these are things that get used for reinforcement learning. So this normalized dynamic, if we apply it to the rewards, sometimes some of the rewards can be, we just discard them. But really, some of the points next to them, we will give some score to them as well. We don't have to be so aggressive. However, at the moment, PPO works really well. So I'm literally kind of shooting fish in a barrel with this kind of thing. Let's do some fun stuff and have them play together. Okay. Now Claudio's going to jump with our drum machine. It's a little crazy. If we can all play to the great AGR in the sky, then it's going to work. Okay. So it's trying to make Kraftwerk, and it's doing a rather good job. Let's try and get it to do something else. So we're going to ask it to make it more raga now. More raga. The interesting thing is that there's always going to be some sounds like this that are no good. So even when I'm making music and just the music, there's always going to be some things I need to discard and throw away. And that's why the volume's low, because this can get really crazy. But let's just give it a bit of chaos. What you find that's kind of interesting, this is a synthesizer that I made 20 years ago. And Claude is giving me the same sounds. So I've been doing the same thing for 20 years. I don't know if that's a good or bad thing, but I find that really interesting, especially when I put the prompts in and use the synthesizer in the correct way. Claude is very good at predicting the sounds, the elements, like very good at their own they know. You just have to give them the correct tools to pull that information out. It techno, electro, jazz, he knows what it is. Let's give it those tools. Now, the one thing that's interesting about this is that this is 24-bit 48 kilohertz. At the moment, with audio engines, audio LLMs, the quality is very low. It's horrendous actually, but the quality of the ideas is very good. Now, we don't need to give the LLMs, FFTs, and all this kind of stuff, we just don't need to give it to them. We can just give them synthesizers and they will just make the music for us. That's been the kind of interesting discovery that's come from this in the past week. And I'd like to thank Tommaso for pushing me to do this, because otherwise you would have had a completely different kind of talk, which I will do someday. Okay, thank you very much.